Hello everybody, welcome to camp, welcome to another episode of Urban Talks. My name is Jiří Jaroš and I work here in Center for Architecture and Metropolitan Planning in Prague. We have here another episode of Urban Talks, a series that is focused on architecture from all around the world. We are focusing on the projects of architecture studios and architects. We talk about them. You can ask questions. As you know, we are using slido.com, chatting platform that you can use for asking your questions. I will see your questions here in my tablet. If you will use website slido.com using a password with hashtag #CampuiOnline, you will be in our chatting room. I will see your questions. I will ask them. And you will get your answers. So use it. We will be really happy to to cooperate on the today's program. I guess that will be really interesting because today we are really happy to invite here Kelly Alvarez Dornan from Mass Design Group. Hello, Kelly.
Hello, good afternoon.
Nice to meet you. I will say for the beginning that Mass Design Group is a team of over than 140 architects, landscape architects, engineers, builders, furniture designers, writers, filmmakers, and researchers from 20 countries across the globe, which is pretty impressive. Mass was named the Architecture Innovator of the Year by Wall Street Journal in 2020. And what is important, Mass Design Group is well known for being a non-profit organization, which I hope we will going to investigate more with Kelly himself. Kelly leads groups London office and also supervising projects in Europe and West Africa, and he worked for Mass since 2014, is that right? And he started in Kigali in Rwanda. Practice grown from 8 people to 80 in 5 years, which is also impressive. And he has also led the design and implementation of several Mass notable projects across Africa. So I think there's a lot of to talk about, Kelly. I'm really happy that you decided to join us. How are you?
Good, thank you. I think for the invitation to come back to Prague. It's been good 21 years.
Yeah. As I mentioned, you have a nice studio. It looks that you you decided to have a professional room for Zooming and video calls.
Exactly. Yeah, keep my neighbor happy.
Great. We are happy to have a clear sound, and I will ask you for a presentation. We are looking forward to your project.
Thank you very much. And we've got about an hour for presentation and questions afterwards, right?
Yeah, right.
Okay, great. So thank you. And yeah, thanks for the invitation. I'm going to speak to Mass's work and do so in a context of climate change today, specifically. Mass stands for a model of architecture that serves society. As you mentioned, we are a team of over 140 various disciplines here at this point, working across quite a wide geography, working in the United States, North America, Canada, Europe, Africa, and now even in Southeast Asia. We started out about 12 years ago with this basic sentiment that architecture is never neutral, that it can either be a positive or negative force. It can either hurt or it can heal. And clearly, I think what we've seen over the last year with COVID is just how detrimental certain architecture can be to human health, specifically. I'd like to kind of also look at this from a climate lens, is that architecture is also never sustainable. I don't think it can claim to be sustainable because it's either in its making and its operation is either a negative or positive act from a climate perspective. And I think it's important for us to move past notions of neutrality and sustainability if we're going to really address the climate emergency. The IPCC is this kind of well-known statement that came out over a year and a half ago now, saying that in this decade, the one we have just over 8.5 years left on, we need to cut the emissions of our current, what our emissions were in 2018 by half by 2030 if we're going to get to carbon neutrality in 2050. And I think it's important for us to focus on this decade as where action needs to happen and not push this down the road and something that we can do by 2050. We do not have time. This is an emergency. It's also important that we think about what is half of what are we going to be having. As architects, as planners, as people in the construction industry, we have a disproportionate responsibility to ask this question. So you can see, 28% is related to the heating, cooling, powering operations of our current building stock. These are all the buildings that already exist. But also there's an 11% annually of just new construction of buildings. And every month, this means across the world, we are adding an entire New York City every month, all 5 boroughs. Every month is being added to the world. So and this is getting kicked up into that operational pie. I think it's time that we really pay attention to this piece of it. It's a compounding problem because every year we're just making the problem bigger too. So I think also adding new buildings to that stock, we need to really think about how to make the reductions of them over their life reduced, and also in retrofitting the buildings to bring the reductions down, do not expend a bunch of embodied carbon in the process. It's a really wicked problem that I think needs to be the focus of everybody in our industry. It's also an urgent problem because this decade, if we're going to have emissions, we need to be really focused on this from a design perspective, because all the emissions that our building stock in the next 9 years will emit will be largely from an embodied side and not an operational side. We're equipped, I think, from the food culture. We begin to see over the last few years kind of literacy around the impacts of our decision making. This is the oat milk I typically buy, and how it stacks up from an emissions perspective against a cow's milk, and where those emissions are happening along the supply chain. On the flip side, from an architectural side, we have little to any of this information historically. It's really difficult to make decisions about our material selection specifically, because we've been speccing materials like this one here, DuPont's XPS foam, thinking we were doing good, only to later find out, in fact, we might not be doing good. And this is largely because I think our focus over the last couple of decades, the conversation around sustainability has focused on operational energy and water use. And it hasn't looked at the entire life cycle of a building. And so now really beginning to see a building as a larger set of decisions, or which the architect planners have the most agency at a cradle to gate and cradle to site part of this. This is before a building opens, before someone comes in there and operates it a way that you didn't intend it to use. This is where all our agency is. Now, reflecting on a project I did for my own family back in Canada. This is a cottage up in the woods north of Toronto. This at the time was designed for kind of off-grid. It's based on a solar array that powers the project. It's situated to organize to the south. It's doing everything right from a kind of environmental strategy perspective. And when written about, was talked about, this is highly sustainable. It's got a tightly insulated structure, part and parcel. And the more I begin to think about the decisions I made 7 years ago, the more I begin to see them in different ways. And this is all the stuff that's on the inside of the cottage. None of it really coming from Canada, as you can see. A lot of it coming from Europe and China. From the outside, this looks like a pretty, it's a wood-framed project. The kind of construction is typical of Canada. And I was curious to think about, okay, well, it's 100% off-grid. That's good. But what is the embodied carbon of this project? And to do so, began to pick apart this detailed model of the project, really understanding, what it's made of, and then ran it through the analysis and found out, wow, this entire cottage is 92 tons of carbon in it. This is basically 92 of my lifetimes are rolled up into this one building for my family. How much I would expend per year, should I live 92 years through my diet. So that's profound as you think about it from an architect. And beyond that, only 10% of that was related to its structure. The majority of it was situated below grade in a crawl space that we don't even occupy, and I've come to reflect upon why I made this decision, and through my education, what I was taught as best practice, or what was contemporary best practice. And beyond that, 58% of it is made up of petrochemicals. And this is really a kind of disturbing fact when you think about the insulation to insulate the foundation. There's decisions I made I would certainly not make again. And I've been thinking a lot about, when I was educated, a decade or so ago, what were the exemplary projects that I looked at? And this was my favorite project in grad school. And the way that this project was represented, and many of its kind, if you were educated in the 2000s like me, the blue foam model in the hands of Ramkulas here was really symbolic of where architecture was at that point. And blue foam is now everywhere. Like it's penetrated our thinking, how we conceive our buildings, and how we make them. This is the Canadian Mortgage and Housing Corporation's handbook for construction, where of the 77 layers of a contemporary Canadian house, 11 of them are made out of petrochemicals. When we think about what actually blue foam is, this is blue foam. It's all these things. It's sure it comes with a decent U value or R value, but it also changes the climate, depletes the ozone, contributes to cancer, terrestrial eutrophication, and a host of other things you probably don't want to think about when you're specifying building materials. And we also know we have alternatives. I mean, this is the kind of amazing thing. We know that there are better options out there, like in this case, wood fiberboard. We just simply don't make the choice or have not been informed to make it. Now, I think at Mass, we've been trying to figure out a way, what is the right language and right way to think about this? And we look to the food system, good, clean, and fair, and how that applies to building. I'll also talk a little bit about how that then applies to the two simple wedges of that pie, how we address our operational emissions through a return to passive systems, and how we reduce that construction pie with a return to a regionalism. So good, clean, and fair for architecture. We believe everyone deserves good design. It's a fundamental right that the design is beautiful and just. It is essential to delivering human rights. And it's an essential service. And I think, again, I think the pandemic over the past year has really illustrated to us the potential for architecture to potentially kill people, right? Or to allow people to get together with confidence. I think so much of our life now is lived outdoors because our architecture has not allowed us to be inside together and feel safe. Clean, that being climate positive is an imperative. Our projects strive not only for efficient operations, but the design of an entire supply chain to be resilient, restorative, and regenerative. And finally, fair, looking at design and construction holistically from the point of extraction to that of assembly and operation to ensure we have safe, equitable labor practices across the entire project and not just on the site itself. Now, I'll talk a little bit about the passive systems and then focus on embodied for the remainder. When you think about where emissions live on this operational pie, so to kind of break it up into smaller pieces here, there's the direct on-site emissions, the things you do in your house, when you go home, if you've got a gas-fired boiler or stove, your air conditioner leaking, that is happening in your house and you have full control over it. And then there's the indirect offsite emissions. And this is basically, when you flick the lights on and the power, the lighting, or if you've got your fridge and all the other things that are running in your house, they're inevitably drawing from a broader grid. And then the question is, how green is your grid? And this is why I think national, energy policy is very important when it comes to buildings. And you can see within it, residential makes up more than half of this, and that makes sense. And the bulk of floor area is residential, and then the remainder there, commercial and other uses. Now, reflecting on most of the projects I'll show you or the work in Rwanda that I've been working with, and when I got there, I noticed, this image on the right was kind of everywhere, and it's been an image, you could go to any part of the world right now, and you would have this image, this kind of 80s facade covered in air conditioners to make the building breathe. It's literally buildings on respirators. And on the left was out of the AA's tropical architecture department, where it was looking at that age of this specific geography. How can buildings be designed? How can their facades mediate, temperature and air quality and allow for buildings to breathe? And somehow in this period of time, architects have forgotten everything we used to know. And we've defaulted to sticking all these machines on our buildings, right? This is a big problem because the knock-on effect of things like air conditioners, this is from Drawdown, which is a pretty well-known publication of how we're actually going to tackle climate change. Refrigerant management is number 4. And on the success of this project, we were asked to look at a lot of other district hospitals and 29 other. And we said, well, how about we give you some basic standards for these other district hospitals? And we looked at all parts of the program and how they should be oriented and organized in the basic flow of patients and staff, et cetera, through them. Out of that, with this intended to guide their procurement, we didn't, help the people hiring the future architects and engineers to say, here's the basic DNA for district hospitals. So, how to organize to the sun, how to organize for natural ventilation again, how to create natural buoyancy in the room and pressure differentials in a facade to get the air changes required in the case of, say, a power outage or not having electricity again. And they then all asked us to test drive it. So this one actually just opened last week. This is in Kigali near Genga District Hospital. It's photos from a couple months ago to kind of proof of concept of this idea. And here's Munini District Hospital again. And this is opening later this year in a much more rural part of the country, but basically taking this DNA and illustrating what it can produce. We were then asked to come to Liberia, which is a very, very different climate than Rwanda. It's coastal, it's hot, it's humid, and it's very, very rainy. And we were given a wetland for a site too. So environmentally could be, couldn't be that much different than, could be more different from Rwanda. We had, again, same basic premise and how do you achieve it? And here working with TransSolar out of Stuttgart, we looked at the same basic first principle stuff again. Where does the wind come from? At what times of year? How do we orient the building? And how do we look at thermal comfort and the range of comfort rather than a specific temperature? How do we make sure that people, throughout the year, throughout a day, are going to be comfortable in a room? Then employed in this a solar chimney as the way to get the air changes, to basically heat up the chimney to draw air up and out of the building. And the architecture really is the machine, as you can see here. Another project in Kigali that's currently going into construction is for the Norquin Foundation out of Stockholm. It's a new innovator hub. And we, again, we're looking at, like, how do we declare we're on the air conditioner? We go back to first principles. So this is the thermal comfort range of office spaces, specifically in the kind of spaces that people need within them. We start looking at what our general thermal cooling strategies are from, what can we do through the envelope, through how the space is designed, ceiling heights, and also, through the day and the kind of diurnal cycle here. At what points can we begin to shrink the indoor air temperature right into that human comfort range through design, and ultimately, went back to looking at the foundations as a way to do it through this thermal labyrinth where air is brought in through the basement and circulated through the foundation structure, and then it cools off naturally in that underground space, and then it comes up into the building pre-cooled. So natural air conditioning. Again, this is, and looking at the building itself, then the cooling system, the air conditioner is supposed to be on the elevation is, out of sight in the basement. Second, the last topic here then will be kind of focused on embodied carbon and this idea of a return to regionalism. So, embodied emissions, that piece of the pie, to expand it a bit more to account for industry itself, because buildings are a part of it, but I think to really tackle climate, we need to look at 3 materials specifically. The first is concrete and cement. It's, as a country, would be the 4th largest emitter by itself. Steel, rebar, clearly a big part of concrete as well, and aluminium, which you'll see in some later examples is in a lot of our facade elements currently in contemporary construction. Now, Getty's, a few decades ago, came up with this valley section to explain the relationship of the city to the hinterland, and how the city needed to be understood in its broader region. Going to update this to Ed Mazzaria of 2030 talks of emissions, where the current emissions profile of buildings there's mountains in our downtown centers where there's high rises and commercial density. and then it's more of a carpet as it goes out to the residential area. And taking these kind of two things and putting them together, beginning to think about how do we actually get to zero is, one, we need to green our mountains. We need to be, thinking about how we, change how our high rises are currently configured, and really change their use. And if you think about I live in London, how many buildings down at Canary Wharf have been sitting empty or half empty for the last year, but the lights are still on? That's the emissions mountain. Our carpets, our housing, how do we change our neighborhoods and our current housing to be both less, reduce our operations, but also greener and a carbon sink potentially? And then the valleys, how do we engage the rural landscape? How do we bring back nature to the broader landscapes around our cities? Now, the first project that got us thinking about this is a school in the middle of Congo, the most remote part of the world I've ever been, where to get there required you to take 3 flights, land on a grass strip, and sit on the back of a motorcycle for 4 hours through the jungle where the path is about as wide as your shoulder in parts. So from a constraint perspective, you could not ask for a better project. And it resulted in thinking about, while we're building this school, to get materials here is incredibly difficult. So we want to make sure that what we do leave, the people can repair and maintain and learn from, right? So we spent 2 weeks there thinking, talking to them, what do you work with? What materials do you use? What are your skills? And then took a bunch of materials back, tested them in the lab to figure out, okay, what are the right building materials for the school? And here you can see, what we did use, we brought in some cement, we brought in some tools and some nails and screws like that, but most of the project was harvested within 10 kilometers of the site itself. It was, the species of wood that we found, a lot of them, the hardwoods, we did a lot of studies with them, and we found that one in particular was perfect, had a lot of tannin, like a cedar for cedar shingles, which you'll see in a second. But these are hand cut, on-site fabricated trusses. Here are the shingles I mentioned here, have that same character as cedar. So in the event they need to replace the roof, throw another shingle as opposed to have to wait for some sheet to show up, months later. And the impact of this too, from a socioeconomic perspective in a country, notorious for a lot of the money funneling its way to Kinshasa and a few pockets, the bulk of this project was spent locally, immediately locally, where of the construction budget, 84% of it made its way into that community. From an embodied carbon perspective, as a result, this project is like embarrassingly skint compared to your global average, or with the Beijing Olympic Stadium here we put there as a comparison. And it makes sense if you're building out of mud bricks and wood, it ought to be quite low, right? So the source here was the cement and some of the foundation mortar. And out of this, doing some work with MIT at the time, we began to look at all our projects. How are we doing across the board? How can we improve? And what projects have performed well, and which ones have not performed so well, so that we can learn lessons from them to apply on others. So a couple of years ago, we opened the University Global Health Equity when we were just starting to think about this, and this was 9/10 of the global average. Looking back when we started, Bataro was half of the global average, which we're interesting, thinking it was kind of interesting to think it was about 20 years ahead of its time in this way. And in pulling this apart conceptually, it'd be understood like, on one hand, the carbon footprint has its corollary with the human handprint, the story that had been told about this project for a while. There's the stones and Hakiza here, and that the climate question is also a social question, and they're inextricably linked. And thinking about how the words of Morris over a century ago ring true to the words of Anne-Marie here, who's the head mason, that the dignity of labor cannot be valued in the same way that we cannot really place value on nature. And so really, to answer the climate question, we need to be answering the social question. And by getting closer to our materials and the people that use them to make our buildings and our cities, we can be better equipped as designers and planners to be practicing responsibly. Now, the project I've been focused on for the last couple of years is the Rwandan Institute for Conservation Agriculture, where this has been learning from Alima in many ways and trying to figure out how to take these lessons at a much bigger scale. the first thing we did was, okay, how do we reduce carbon radically in this? And the biggest savings was going to stone foundations, something I've thought about a lot since. Like, why do we just assume foundations need to be cast concrete? We've been building out of stone for centuries and centuries and centuries. And then suddenly in 1930, we said that's not good anymore. So by going back to stone, it had the biggest profound cuts in the overall embodied carbon. Wood framed roofs, coffee husk fired ceramic roofing. This is an architecture, literally harvested from the site. Our engineering team spent time, for the rammed earth and the earth blocks, digging holes on site, finding the right mixtures of clays and soils to make, get the recipe right, so to speak. So this is all on-site sourced material, and then they're kind of testing here. We're working with a few lumber suppliers across Rwanda and Tanzania, like what species do they have? What dimensions can they cut? What's their drying time? To think about how we design around the constraints of the supply chain as opposed to the other way around. And from an EPD perspective, these are environmental product declarations. This is a Swedish group that does a few of them. And you can see a lot of our projects are in parts of the world where these do not exist. So these are the coefficients that you assign to a material to figure out your footprint. So, in the absence of data, we've been working with our manufacturers to create the data. And so here is an overview of the supply chain of Reliva, the big ceramics company we've engaged in this project, and others to understand their whole supply chain and where emissions happen across it. And then take this and roll it into our own little custom spreadsheet to think about how then we can bring this to other projects and get everybody thinking about this on the design team. The results are pretty profound. So had we just kind of gone the business as usual case on the left, you can see compared to the right there, our project, it's got a 58% reduction. We're not net zero at all, but we're certainly on the way to the 2030 target. 96% of this project's material are extracted, harvested, sourced in Rwanda. And Rwanda is the size of the Netherlands, for context. Within a mile, we got all the big heavy stuff, the soils, some of the timber, the water that we're using. Within 10 miles, the stone, the aggregate, the sand. At 100 miles across Rwanda, and then we're getting into things like the cement and terracottas that you saw before, and some of the other items that we could specify in country. At 1,000 miles, this is where we're reaching out to Kenya and Tanzania and Zambia for some of the wiring and hardware. Things are not manufactured in Rwanda. And then finally, globally, we're having to go to China, the Middle East, and Europe for things like the wastewater treatment plant and the solar PV. 98% of the labor sourced within 100 miles. So of a $60 million capital project, again, this is how to make sure that you're having impact. Looking at that, we hired basically every able man and woman in the district through this project, through the construction. At any point, we've had upwards of 900 people on the project site at a time. We found local craftspeople and artisans to supply things like the ceramic tiles. This is Waleris, who's kind of godfather of ceramics in the country, where we handmade all the tiles for the wet spaces. We worked with various cooperatives here weaving sisal for the light fixtures in the space. We also designed all the furniture and the interiors for this project. We reached out to the metal workers to do custom little hardware details and frames and things for the furniture. And finally, we made our own wood shop. We hired a couple carpenters to do a lot of the desks and chairs for this university. So here you can begin to see what it looks like on the interior. And this is a banana weaver cooperative. So banana fibers, there's a lot comes off the plant besides the banana, more than the bananas, and taking this and incorporating into the residential furniture suite. To think about, okay, how do we get to net zero? How do we actually get to climate positive? We've been working with Atelier 10 out of London to think about what the total footprint is. So we had a good sense of what our buildings were. We have a good sense of what the infrastructure is, and that's all of the carbon associated with the construction of the roads and the solar PV system, the landscape, all of the paths and the stone and the things that are laid into the landscape. And then because the campus is entirely off-grid, the operations budget is basically zero from a carbon perspective. It's a completely off-grid project from both a power and water perspective. So we have the benefit of 1,200 hectares to then think about how do we get positive. And we're developing a reforestation scheme where we plant 40 hectares. And over this decade, think about how do we get to neutral and how does it become positive thereafter. So here you can see this kind of stacking of the footprint in the positive direction there through the phases of the construction. And once the reforestation scheme kicks in, per year, you begin to sequester a certain amount that takes that down and steps it down. And so this, albeit on a project site where we have the area to do it, this as a diagram is really how I think we need to be thinking about architecture and finding that green space and developing relationships directly to it and not some like abstract offset that we spend $5 on, but actually figuring exactly where that's actually going. Now, typically, this might be the question you fired already. This is one I get at this lecture all the time, which is great. You can do this in a place like Rwanda, but how do you do it in Prague, right? And I've been teaching at the University of Toronto for the last 5 months to answer that very question. I mean, we're working on this in our project in the United States right now, and this is the city of Toronto in Canada, where I'm from. And so I've been focused, okay, so what is it that we have to do in a, say, European, North American context? You put it there. So how do we have the emissions of all future constructions and existing operations in Canada this decade? And so this is the studio, if you want to follow it on Instagram. This is the half studio, I've called it, in Toronto. Canadians are pretty filthy, I have to say. We've got 3 times the average carbon footprint of humans on Earth, only beaten by a few countries in the Middle East here. So we emit a lot, and we can do a lot better to improve. And our buildings are a big part of that. Clearly Canada's a cold country. That's also spaced far too apart, but our buildings are oversized and we take too much time to heat them, or we use too much energy to heat and cool them. That said, the city of Vancouver, this came out in November, just this last year, the first city in the world to have embodied carbon targets as part of its climate emergency action plan, and something I'm really proud about, and thinking about how are all cities going to follow. So right now, London is pursuing something similar. I know Finland is, and if Prague is not yet, hopefully this conversation can help push it in that direction. What Vancouver did in 2018 is basically go out and produce a benchmarking study. It looked at 50 or so projects built in the city, and to answer the question, what are they building right now? Like, we need to get to half. Okay, what are we doing today? Right? We need a target to measure against. So I enlisted 10 firms in Toronto to offer contemporary projects, either in the ground or recently completed, to answer that question, like what is right now, so that students can help then understand where they're moving from. We worked with them to develop kind of full bills of quantities and pick the buildings apart. So, well, the calculations include the main things like the structure and the envelope, interiors, but did not include MEP systems and a number of other things. So it's an incomplete accounting. But the results were really interesting. I'll be sharing this with the City of Toronto and Canadian architects. And it's a kind of form of construction I can't imagine is all that different from Czech. So we found that the low-rise projects built out of wood frame were roughly half per square meter of the projects mid-rise and high-rise built out of reinforced concrete frames. So if there was something you wanted to do right now to save the world, it'd be like, build more lighter, lower buildings. That would be a kind of simple thing based on the technology we have. And kind of getting into the weeds of it, the key findings which I've shared with the city and now going to share with the broader country and now sharing with you is like 4 main drivers we should look at from a planning perspective and as designers where we can focus some attention. And the first is carbon intensive structural systems. This is really straightforward, cast in place reinforced concrete because of cement and because of the rebar in it. Is a huge driver of emissions in all these projects. And like I said, the lower rise projects that had wood frame had roughly half that of their counterparts. So, recommend talking to your structural engineer, thinking about how to make your buildings lighter, reducing cement as much as possible, and looking at alternative structural systems. We're talking a lot about mass timber these days, and this is one of the reasons why. Looking at a few of the buildings and proportionately where emissions live, and you can see, we'll get into a few of these here, but the concrete, that red it sticks out at you. You can see, in a couple of these projects, the one Cameron Street project, it's the majority of the project is concrete. After that, aluminum and steel, and also in a smaller project, some projects, insulation. As architects, we are completely in charge of envelope. So envelope systems are a big source as well. And so XPS insulation, which the North American versions of has been abhorrent until recently in Canada, the laws have been changed to follow more European standards. And aluminium, wall systems. So there's a lot of window wall systems in Toronto and Canada, and curtain wall certainly uses a lot of aluminium. So the sourcing and smelting of these materials is energy intensive, albeit they could be recycled, but they are a problem from an emissions perspective. So, recommendation is like, get this foam out of your buildings, find organic sources for thermal comfort, for insulation systems, and let's figure out ways to cut the amount of metal in our aluminum in our wall assemblies. And so here, just one student looked at just the two options for insulation on a project, and you can see, one is 1/5 that of the other, and the one on the left is what is readily used in Canada, unfortunately, and what are kind of where emissions live in the wall section. So it's, again, the irony of the material that's intended to keep us warm is also the one that's warming the planet the most. Subgrade floor area, and this is probably more, there's planners at the audience. I would love to know what the parking requirements are in Prague or in the Czech Republic more broadly, but Canada has this fascination with digging basements. I grew up with the basement. I just thought every house had a basement until I moved to London and realized no one really has them here. But foundation works and parking structures and anything that's been pushing people into the ground architecturally in Toronto is a huge, huge source of emissions. This is largely due to on-site parking requirements and floor area ratios. So I imagine there might be something similar, but like basically in Canada, any floor area below grade is not included in your FAR accounting. So you can go as deep as you want, kind of, and penalized. Cost more, but that's typically where people put their parking. Now, looking at a building from an emissions profile, what's interesting is these 3- and 4-story wood frame townhouses. The bulk of the emissions are all on the foundations, these concrete foundations. Again, kind of, it's the disproportionate. Gets even more out of whack at the mid-rise. In a couple of these projects here where the soil conditions are a bit more difficult, where half of the emissions are in the parking garage for a 7-story residential building, right? Where just to house our cars, we're emitting just as much carbon as the house in itself. The one project that didn't, it could not go down for some site constraint reasons. And then the high rises, again, you see these large parkades below ground to accommodate all the units above ground. And from an emissions perspective are kind of icebergs. One student just like, well, I just get rid of the parking and we've met our 2030 targets. And she was pretty much right there. So that would be the easiest thing to do. And the last is the dimensional impact of parking, which is, the parking grid does not necessarily match up to the residential grid. So in this project, you can see the parking grid is a 5,500 grid and the units above are on a 64. And so to accommodate that change in grid, the whole ground floor slab is a meter thick transfer beam, 14% of the project's total emission, once again, just to accommodate parking. Misplaced. I will leave it there and have some time for questions. Thank you.
Thank you very much. Thank you very much for your talk and all the projects you showed us. I think it's pretty impressive how deeply you are focused on the sustainability and emissions, especially the last thing about the ratio in terms of garages. It's very interesting. Also in Prague, we have that rule that if you build a residential house, you have to provide a parking space for every flat in that building. which means that you build 6 stories building, you will build 3 stories of parking for that people, which means that half of the price of the building is just for cars.
Parking spot.
Yeah, but of course we are in the crisis if we talk about the residential houses and about the building, about the living for people, about the flats and apartments. So that's quite interesting. I want to ask you about the reusing of materials. You showed us that in Africa you can use different materials, and you learn people to use different materials. What do you think about the reusing of the concrete? If you build a typical development in the city, for example, an office, and you will reuse some old concrete from old building for a foundation, for example, do you think that this is enough? I think it's just an experiment for now.
Maybe. I mean, the first thing is just don't tear down the building. That's the obvious thing. Like, keep it and reuse it for another purpose, and keep that concrete exactly where it is. Concrete is reconstituted stone. I mean, that's what it is. It's the MDF of, stone, basically. I don't know if the MDF is the same in Czech, the particle board, right? You're taking a tree, you're making sawdust out of it, you're gluing it together, and that's what concrete is. Where the more you think about why we use so much of it, the more I really wonder why we got away from stone. So to reuse it in a building, I guess my question would be for an engineer: can you cut it? Can you put it back in structural applications? What else do you need to do to it to make it stand up? But certainly, I know there's a lot of people out there as far as how you could crush it and reaggregate it and use it as a has to be a core part of our education and how we're thinking about the future of our cities. We need to stop building so much, and we need to start taking care of what we already have.
Yeah. We were talking with my friends about the fact that in Africa and other worlds like Africa, people are skipping technologies. For example, in payment, they don't use credit cards. They use mobile payments. They don't use desktop computers. Then they use mobile phones. And do you think that they can skip the era of the high emission and just jump straight into the era of sustainability?
I hope so. I hope so. I am concerned about the influence of certain supply chains and the look and feel of buildings, and the bulk of your kind of commercial architecture in Rwanda are like, low grade curtain walls, and reliant on air conditioners. And that's contemporary. That's what's deemed progressive and, keeping up with the pace of, the world. And I think we're, who's to blame? I think like if it would be great if we don't have to start making horrible copies of 60s high rises everywhere around the world. That would be nice to get back to how we built, I would say 100 years ago, when we actually knew what we were doing.
If you go back to your time in Rwanda, do you recognize some influence there? Do you think that your work or work of Mas is inspiration for other studios in Africa?
Yeah. We've seen, we're working with the government on things like building codes to get, like lower carbon earth blocks and stuff into the building code. So we're doing things from the policy side to help push it in that direction. And then also like the stone wall in the Baturo Hospital, which is really the kind of calling card of that project. We've seen the people that we worked with to do it are now, have their own construction company specializing in it. They're doing like high-end hotels and restaurants around the country. So, you see a detail cut and paste in multiple places now, which has been really encouraging.
Yeah, I have some questions from our fans here. First is, if you would use timer wood as a construction material only, maybe it's a timber. Sorry, no timer.
Timber, yeah.
Timber,
yeah.
Wood
yeah.
as a construction material only. You can't go mid-high-rise buildings, so that you would sprawl the city more to the nature. Isn't that counterproductive? What would be the right balance between sprawl and height of the buildings?
Good question. I mean, it depends where you are. I depends what you consider even high rise. but looking at a lot of cities, like we've been focused on Toronto, answering this question is by going high, you're not solving any problems because you have to big bulky foundations. I think that the density that I imagine cities like Toronto need to get to are probably density similar to what Prague currently has and what a lot of continental European cities, have been historically. They have a fabric that is a mid-rise high density. And I think wood construction, we know, again, I'll take Prague as an example. How much of Prague is framed out of wood? I imagine most of the historic buildings were stone, brick, and wood. And, I just think, again, the more we could look at what we built with over a century ago, the more clues there might be about where we need to go.
Thank you. Another question from Pavel. Do you use ISO standardized for LCA for the calculations of environmental impacts, or do you use your own? If so, is there a big difference between them?
Yeah, no, we do. So even the stuff we did in Rwanda, we're cribbing the coefficients we're taking from some of the UK studies. So again, it's not a perfect math because cement in Rwanda isn't necessarily as even clean as the stuff in, say, Europe. So in those cases, we've been working on actually been working right now to get the first EPD for a cement manufacturer as well. But the studies that I showed you here is using a software, if you're not familiar with it, one-click LCA out of Finland that aggregates, these databases and pulls it together. So yes, we are in those cases we're following kind of industry practice.
Yeah, you were talking about the local materials, and I would like to ask you about local architects. What is their situation in Africa? Because I remember the TED talk of Christian Benaimana, and you were talking about the situation of architects and how he came back to Africa. Do you have some notes about that?
Yeah, well, watch Christian's TED talk. It's a great time to be, it was a really good time to be an architect in Africa. We started in Rwanda, a country of 12 million people. There were like 12 architects. And we helped start the first school, and, that's why we've grown so quickly. It's a rapidly building part of the world, and there weren't a lot of architects or engineers. And so we were trying to, fill that niche a little bit. And I think it's, I always said to them, it's like, I got a little envy for you. You're graduating, you're going to have work for the rest of your life, no problem. Just for the demand and the lack of architects. And I think it's a really exciting time to see what's going to happen with this generation.
There's another question. It's simple. 3 main differences between First World and Africa, and what is better in Africa in terms of being architect and creating there?
3 different. I take objection with the basic framing of the question, but I'd say, okay, like practicing in Rwanda versus practicing in Canada. I'll reframe it that way. So, the best thing about practicing in Rwanda taught me everything, about architecture that I never knew, and told me that I needed to completely relearn what I thought I knew, because it put you face to face with your decisions. When you're sourcing something where you actually know who's making it and you're thinking about them, you design differently. And the first, I think that was the first great advantage. My supply chain wasn't this abstract thing I didn't think about. The second thing was the weather is perfect. So you didn't have to worry about insulation and air barrier. You just had to worry about how do you get as much air going through this building at all time. The tropics are, liberating in that regard from an architecture perspective. So that was nice. And yeah, I think the third part was just the culture of the practice. It's a really young, energetic, exciting place to be, of a lot of different nationalities and a lot of young Africans. So that would be the third part.
Well, yeah, there is another question about the heaters in winter here in Europe and air conditioning during the summer, and the situation in Africa, because there is warm weather, very warm weather, and maybe it's more wet than in. There is more humidity in the air. in Czech Republic we don't have that, but if we use air conditioning and if we use heaters in during the winter, isn't that really worse, the version of trying to work with nature, work with climate? Because I can imagine what's happening to the nature if we use this.
Well, I'll try to maybe, if you could, like, heating is not as bad as cooling right now, because, you know, cooling uses refrigerants, and that's the problem. It's kind of highlighted with drawdown. So, like, we should not be using air conditioning, full stop. There's, like, what part of the world did we inhabit and evolve to where we required air conditioning? We didn't. Humans and our architecture, you know, up until the invention of the air conditioner by Carrier last century, we didn't have it. What did we do? We learned how to design for cooling where it was required. Now, you know, buildings in this part of the world, I'll speak to, like, continental Europe. How many days of the year do you really need an air conditioner? Like, 0, I would argue. And it's a question of, like, our architecture being able to breathe again for itself and not be so driven by HVAC or HVAC or whatever you would call it. I mean, that's the problem. It's not that it's too hot, it's that our buildings get too hot, right? And because we've got really shitty architecture. And the heating part, like, you know, we live in a cold climate. I don't know what the temperature is in Czech right now, but, like, the last week in London, you know, there's actually ice on the water. It's been nostalgic for me being from the middle of Canada. But yeah, we have to heat our buildings. We have for centuries and millennia. And the good news is, you know, if you've got electric baseboard heating and your grid is, you know, green and, like, you know, moving to renewables, like, it's not as big of a problem as opposed to trying to cool our buildings. And, you know, Africa is a big, big continent. There's a lot of parts that are really cold, and there's a lot of parts that are really hot. And there's a lot of parts that have big cycles of seasonal change throughout the year. So, you know, I think any place needs to be, I would just, again, look at the architecture from 100 years ago before air conditioning happened. And how did people heat and cool their buildings, you know, and there'll be lots of clues there for us, as opposed to what we're currently doing, which is, you know, hermetically sealing it and plugging it into something.
Thank you. There is another question, and I'm happy for that one. What do you think about the new city plans like the Line in Saudi Arabia? If you heard about it, is there a sustainable way of building in huge scale in circumstances like a desert?
No.
That's all.
I mean, the word Saudi Arabia and sustainability in the same sentence doesn't make a lot of sense to me.
And did you hear about the Line? About that?
No, I have no idea.
No? It's a plan for a huge city connected just in one line. There will be some hubs for people, for citizens, and it will be designed like you are able to reach every point you need, every service, every shop, and everybody in a few minutes just by traveling in high-speed trains or something like that. So it's pretty impressive across the Saudi Arabia. So you will find it. I think it's on Wired.com. You will find it there.
I'll look at it.
So
yeah.
you can check it.
It sounds like Canada.
Yeah,
it's a bunch of cities on one line.
Yeah, it's pretty sci-fi. So we will see if it's happened. And question about the mass design group itself, because we have a lot of funds that are also students of architects, and I always ask about how architecture studios all around the world works. What's the structure of the company? Because you said that, or I mentioned that on the beginning, that it's team over 140 architects, landscape architects, and everyone from all around the world. How do you work together? Is that like
there are a lot of Zoom right now? But
is it like there are a lot of small businesses and people cooperate together if they have good mood and ask somewhere if he has time to do it?
We started in Rwanda, and our first project was there, and we have an office in Kigali and in Boston initially. And a lot of the work was based in Rwanda, and the implementation team and the design team was kind of going back and forth. And now, the Kigali office is 80-something people doing, focusing on work in Africa and Asia. And we have an office, and I'm here in London. We have folks in Boston, and we have folks in Santa Fe, New Mexico, looking at projects in the Americas. It's basically how it's organized spatially, right? And then, I think that the part about is we're a nonprofit that everybody's like, how does that work? And, we looked at, a business model that would allow for us to figure out ways to fund projects and work with people that otherwise wouldn't afford architecture. And by being a nonprofit in the United States, you can fundraise. So, this year, roughly 20% of our total revenue is through fundraising, which we then take and use it to work with people that we think, deserve design or should, not deserve, but like need access to design to improve their, situation. So we work with a lot of organizations or where they're subsidizing our work, or we're providing it through a catalyst fund to say, we're going to give you design service to help unlock the funding to make this project happen. And, instead of working on speculative work for a developer who can completely pay you, I'm sure they can afford to pay you, but so many architects who spend so much time working for free, either through competitions or on speculative development, just imagine, instead of giving away your labor and your ideas to people who could afford them, to give it to people who need them. And that's that's basically why we're doing what we're doing.
Are students contacting you to cooperate with you, maybe in terms of internships? And
Yes. Yeah. A lot. Yeah, certainly. We offer internships. We're always looking for talented people. Yeah.
And the final question: do you have some advice for students of architecture in these days?
Yeah. Sure. I mean, if you didn't take it away from my lecture, the climate emergency is what you should be focused on. I mean, everything else is secondary in my mind from an architectural perspective and feeds into it. It's all related, but I think in my mind, it's the forefront. And I think it's so tied to social, social justice and climate justice are the same thing. I think and then the second thing is don't work for free. Don't work for free anytime in your life. And go find, go work with people who value and that you can contribute, your ideas and your labor in positive ways. Those are my two pieces of advice. Having done a lot of work for free in my life.
It's very wise. Thank you for that. I think that's it. Thank you very much for your talk. Thank you for your time. It was my pleasure to share this time with you. That's all. Thank you. If you have something to say.
No, thank you again. That was it's fun to talk virtually in Prague.
Okay, thank you, Kelly. Thank you, Kelly. Thank you very much.
Take care. Good night.
Thank you for watching us. If you're interested to see the recorded stream, you will find it on Facebook and YouTube. And you can join us in 30 minutes on Clubhouse. We will discuss this talk with my friends from Institute of Planning and City Development here in Prague, with my colleagues. And we will talk about the work of Mass Design Group. We will talk about the talk we just heard. So have a good night and see you sometime.